Language of Algebra. Simplification. Complicated algebraic expressions can often be reduced to a much simpler form using properties of real numbers and the order of operations. We often use the acronym PEMDAS to help students remember the order of operations: parentheses, exponents, multiplication, division, addition, subtraction. This simply means we simplify complicated algebraic expressions in this order: parentheses first, exponents, then multiplication, division, then finally addition and subtraction. For example, we simplify the following expression: 3 times 2 plus 1 squared minus 14 divided by 3 plus 4 plus 5 in the following manner. Using the acronym the P, parentheses, tells us we simplify what's in the parentheses first and get 3 times 3 squared minus 14 divided by 7 plus 5. The E, for exponents, tells us we simplify wherever there are exponents to get 3 times 9 minus 14 divided by 7 plus 5. The M and D say we simplify multiplication and division next. We get 27 minus 2 plus 5. And the addition and subtraction we simplify last to see the entire expression simplifies to 30. Properties of real numbers. We'll talk about the associative property of addition, the associative property of multiplication, the commutative property of addition, and the commutative property of multiplication. And finally, the distributive property, which is the most useful of all the properties of real numbers. The associative property of addition allows us to move parentheses in an expression where all the numbers are added together. For any real numbers, a, b, and c, we see that a plus b plus c is the same as a plus b plus c. Changing the variables for numbers, we see 3 plus 4 plus 5 is the same as 3 plus 4 plus 5. The associative property of multiplication allows us to move parentheses in an expression where all the numbers are multiplied together. For real numbers a, b, and c, a times b times c is equal to a times b times c. Applying this with numbers, we see that 3 times 4 times 5 is the same as 3 times 4 times 5. You can use your calculator to verify this. The commutative property of addition allows us to change the order of any two numbers added together. For real numbers a and b, this simply means a plus b is equal to b plus a. Using numbers instead of variables, we see that 3 plus 4 is equal to 4 plus 3. The commutative property of multiplication allows us to change the order of any two numbers multiplied together. For real numbers a and b, a times b is equal to b times a. Using numbers, 3 times 4 is equal to 4 times 3. The distributive property allows us to multiply through an expression in parentheses. For real numbers a, b, and c, a times b plus c is equal to ab plus ac. This is because we can multiply a times b and the a times c, keeping the addition sign in the middle, to get a times b plus a times c. Using numbers, we say 3 times 4 plus 5 is equal to 3 times 4 plus 3 times 5, or 12 plus 15. Another example, 3 times x plus 5 is equal to 3 times x plus 3 times 5, or 3x plus 15. An algebraic term is one number, variable, or product of numbers and variables in an algebraic expression. For example, the expression 5a plus b minus 7c plus 2 has terms 5a, b, 7c, and 2. You already know the letters represent variables. The number multiplied times the variable is called its coefficient. So 5 is a coefficient of a, 7 is a coefficient of c, 1 is the coefficient of b, though you can't see the 1. A number without a variable is called a constant, so in this expression 2 is a constant. Like terms are terms that have exactly the same variables, and those variables have exactly the same exponents. For example, some like terms, 3a and 4a are like terms. X and 5x are like terms. 7ab and 10ab are like terms. And 5c squared and 3c squared are like terms, because the variables in each of these pairs are the same with the same exponents. We can simplify algebraic expressions by combining like terms. In an algebraic expression, like terms can be combined by adding or subtracting their coefficients. For example, 3a plus 4a, we add the coefficients and get 7a. 5x minus 3x, we subtract the coefficients and get 2x. In the expression 7b plus 5a plus 3b minus 6a, we add the coefficients of b and subtract the coefficients of a to get 10b minus 1a. We rarely write 1 as a coefficient. When you don't see a coefficient, it's understood. So this is the same as 10b minus a.